Hello, everyone, and welcome to the TRATON Group webcast on battery technology for heavy commercial vehicles. My name is Claudia Fuhrmann, and I will be guiding you through this session. The transportation industry is undergoing a major transformation, and at the heart of this transformation is or are battery electric vehicles. Battery technology has improved significantly in recent years, which makes them not only suitable for urban distribution, but also for the long-haul segment. At the TRATON Group, we are preparing every possible aspect for the electric era. Our brands already offer electric trucks and buses. We established the mileage charging joint venture last year, and in September, we opened a new battery factory in Södertälje, Sweden. On our agenda today are the three key areas: heavy-duty truck use cases and factors to consider when developing new cell technologies, battery architecture and integration into the vehicle, and last but not least, elements of a battery life cycle, including end-of-life battery recycling. For our discussion, we welcome 4 experts from TRATON, MAN, and Scania. And following our panel talk, we'll have a Q&A session where you can ask your fresh questions. So feel free to submit your questions in the chat box. Please note that the webcast will be recorded and published on our website afterwards. Now let's kick off our webcast. For a long time, there used to be the prejudice that heavy-duty trucks could not be electrified because of the long distances they cover and the high costs of batteries. This assumption has already been debunked, as demonstrated by first use cases from our brands Scania and MAN. Batteries have found their way into the heavy commercial vehicle sector. Cell chemistries and battery architectures are constantly evolving, and a new generation of batteries is already on the horizon. So now it's a good time to take a look at how far batteries have come. To begin, let's focus on our customers, the typical use cases for electric trucks, and the challenges we face when developing batteries. So let's welcome Dr. Götz von Esebeck, TRATON's Head of Technology Strategy and Innovation, and Dr. Stefan Tillmann, Product Manager Batteries within the TRATON Group. Hello. So, Götz, there are a number of critical factors to consider when developing batteries for heavy-duty electric vehicles. Could you tell us a little bit more about the typical applications of these vehicles and why they play such an important role when developing batteries?
Now, first, it's important to understand why batteries or which requirements, which specifications for batteries for commercial vehicles are important and why. So we have to look in the so-called use cases we have or we see in commercial vehicles. And there is, you mentioned it in your introduction already, the long haul and the distribution is the main areas. The distribution even includes trucks for distribution, but also city buses in the urban area. These are 2 of the main use cases or main applications, but there are a lot more we identified, so are working with more than 500 use cases. All of them have this high annual mileage as an important topic and the long lifetime, especially compared to passenger cars. And there are a lot of customized specifications. Important is also the uptime, so the vehicle have to run to bring our customer the benefit. So they are industry products and they need to make money for our customer. But in general, we have to say the cell chemistry for commercial vehicle is not a totally new chemistry. It's it is an adaptation compared to the general or more front runner, let me say, of passenger cars.
Can you give us some more details on the 2 typical use cases?
Yeah, sure, of course. First, maybe starting with the long haulage. If you look at that application, at that use case, we see an average of 130 to 160,000 kilometers a year, which is of course a lot. They run an average 520 kilometers per day and even up to 250 days a year. In the long-haul application, there's also important in Europe due to the European regulation that the vehicle can run 2 times 4.5 hours, but have a mandatory break for the driver of 45 minutes. And that's an interesting point, of course, for a battery electric vehicle. That time can be used then for charging the vehicle, so that the second 4.5 hours can be run then on that battery. And that's, of course, a very important difference also to passenger cars. We have a high charging cycle numbers due to the daily drive, the charging in between overnight charging, and a high energy throughput per cell. That has to be taken into consideration when designing and developing the batteries and the battery cells. A new standard is coming also for the charging for trucks, especially the long-haul trucks, the so-called megawatt charging. So we then charge the vehicle with a high power. Usually high power charging for a battery means a high stress for the battery, but not in our commercial vehicle case with this megawatt charging, because we have a quite high or quite big battery. So the stress on the battery, the so-called C rate for in case of charging, is not so big compared even to passenger cars with high power. So that helps, of course, in the lifetime then of the battery.
That was the long-haul segment. What about urban distributions? What are the requirements there?
Now, urban distribution, the use case looks a lot different than the long haulage. There we have shorter distances. We have more frequent stops. If you think about city buses or distribution in the cities, of course, with all the stops there. So we see an average of 65,000 kilometers a year, and they run 300, 350 days a year. So the battery can be there optimized for lower weight, for lower cost, and not such ultra long range is needed as we see it in the long haulage application. That then we can optimize the battery for that use case. But in general, again, our products are for our customer an investment good. They need to pay off, so the battery has to meet the demands, the vehicles have to run and fulfill the demands.
But it's not only the different use cases that need to be considered when developing batteries. I think the next question, Stefan, is for you. The intended region of use also plays an important role. Can you tell us a little bit more about that?
Yes, TRATON is developing a modular kit for those batteries that we will use across all brands within the TRATON group. And for this development, there's for sure the specification based on our extended use case analysis that Götz has presented. And this is also the basis how we will come up with a solution that fits all brands within TRATON. And the major forces that we need to look on is for sure the environment and the mechanical forces coming in the vehicle, but it's also local regulations and also the supply chain considerations that will help us to make a good choice how to do this modular kit. And for example, coping with climate constraints and conditions, we will have a system where we have an advanced kit to heat and cool the batteries. For example, in cold countries like Scandinavia, we need to heat the batteries in wintertime to optimize towards performance, but also charge and discharge power. And in hot climate like Spain, we need to cool the batteries to have a good fit to aging, which is prominent in higher temperatures, but also to keep the battery in the limit of the specification. So that's what we are doing here, and for sure customer demands the central drive force to optimize the batteries so that we have a good fit for what the customer is asking for. And yes, major considerations beside what I just described is the environmental regulations that we have to work with, safety standards which vary across the markets, and also recycling law that can alter what we do, and we need to find a good fit altogether. And the strategic approach in TRATON is to develop a common modular setup that we can use across all brands.
Thank you, Götz and Stefan, for this comprehensive overview. Now, let's take a look at the individual components and at TRATON. The TRATON Group has a very diverse product portfolio, so modularity is key. It not only enables synergies and scale, but it also allows us to be prepared for local supply issues and market disruptions. Stefan, you already mentioned the TRATON modular setup. What does this mean for batteries?
Yeah, basically, you need to understand that commercial vehicles are based on a frame structure where every big component is being attached to, like cabins, axles, drive lines, but also our batteries. So we mount them on this frame. And for the near future, we will see that we will not have the space in between the frame available because there are still parts of the drive line. So most batteries are mounted outside the frame, hanging on the sides. In the future, we are looking onto a more optimized setup where we have maybe electrified axles, where we gain the space in between the frame also for batteries so that we can have a better fit for the customer, how to place the batteries to optimize for his specific application. So that's, from our perspective, one of the major things in the TRATON Group to do so. And what we are doing also with the TRATON management, we are looking onto optimizing towards the application into a, let's say, setup where we say, what is the driving range, what is the the recharging time, but also payload penalties. If you have a full setup of batteries, then this is heavy, but maybe, as Götz described, not for every application it's necessary, so you can balance this to the right application.
So you just mentioned the battery. When we talk about batteries, we usually mean the whole unit, so the battery pack.
Yeah.
But the battery pack itself is made up of modules. So can you explain how exactly a battery is built?
Yes, we are supplying cell from our suppliers with specification according to our setup. There we have conducted what is the requirement on the cell to cope with our loads, to say. And then we are building in our factory from the cells the modules, and those modules might be something like 15 to 20 cells in a pack, and those will be then fit into a battery package which has different forms to fit into the specific space on the frame. And that's then at the end of the optimization that we drive so that we have good fit of the batteries to the frame and to the application. For example, some customers may need to have free space along the frame to fit in some pillars or hydraulic pumps or something like that. So you cannot populate everything everywhere. That's also part of what we do in our business, to find solutions for the customer.
So how many cells would go into a vehicle usually?
Something between 180 and 200 cells, but we will have, when we have the decision clear, we will have all packs on the same level so that we can have the form factors being mixed up, but not the chemistries. That's impossible. So that's. So when we look into what's the composition of a pack, that's not only the cell, the modules, and the mechanics, but also the battery management system, which means hardware and software to control the stuff, and also the cooling system. So, what are the chemistries we're looking at? That's we're looking at nickel, manganese, cobalt chemistries, which is a very common chemistry, and then we are looking on low-cost chemistry, which is called LCC, where we have the main focus on the LFP, the lithium iron phosphide cells. And basically the cells are very similar, except the cathode side, where we have the different compositions of those materials, which is giving the names to the cell. The NMC, or nickel, manganese, cobalt cells, have a higher performance with a higher price tag, while the LFP cells or LCC cells, low-cost chemistries, they have a lower performance due to lower voltage per cell, but with a higher lifetime and also with the more affordable price for cost-sensitive applications. And yeah, as you said, we are starting up a factory in Södertälje for the production of Scania, and we will in future do the same thing in Nuremberg for MAN. That's the situation right now. Go on.
So yeah, one question which is always important for our customer is like the price. That's another question for you. Do you think that new cell technologies will make battery electric vehicles cheaper in the long term?
First, in general, it's very difficult to predict the battery costs. But the issue is we see here is that we are very much depending on the raw material, and there we have seen just recently some high fluctuation on the raw material prices due to the geopolitical topics. That's why it's also very important really to look in different aspects how you can get rid of some of the most valuable and most costly materials like nickel and cobalt, for example. On the other hand, of course, it's also important, and we come later to that, to the recycling, to ramp up the recycling, that you can get the material then back. But in general, on the long run, we see a decrease on the cost of batteries. But again, very volatile on the raw material. But there are other 10 developments really to decrease then these costs to get the best TCO for our customer.
So what developments can we expect for truck batteries?
In general, there's a continuous discussion there on batteries, on different materials. If you make an outlook on the electric truck batteries, we will see quite fast changing technologies there. So every 3 years we see a different adoption, a different content of that material. So on the adaptation of the products, an update of mix of chemistry in a different way. But that's not only on the cells, but also on the whole battery pack, of course, optimization of the pack and the software as well.
Okay, so yeah, you already mentioned there is more than just the cell chemistry which improves the trends for batteries. What else is there?
Yeah, there are a lot of different topics to consider. First, for example, maybe I can jump back also on the chemistry. One is the continuous development, but we see also some revolutionary step in the battery chemistry, which we see currently in the research area, like all solid state lithium sulfur and lithium air. One example is, for example, the all solid state, which uses solid electrolytes instead of liquid. That has a potential for huge improvements, like higher energy density. It will be safer. It will allow faster charging. But there's always a trade of the different properties and cost, of course. But that's on the chemistry. Other issues or other developments are also on the manufacturing of the cells, which is improved by dry coating, water-based coating, items like that to be even more sustainable. But also on the pack itself, like the topic of immersion cooling, so optimizing the cooling for a longer lifetime. And topics like that, but also working on cell-to-pack, cell-to-vehicle developments, improving the charging process, and optimizing the battery management as well to have a better prediction of aging. So all that will improve the battery and helping us to get the better properties for our customers. But in general, so battery development is continuous and quite fast. We will see safer, less costly, and better performance of cells as well as the packs.
Okay, thank you, Götz and Stefan. I think they were very valuable insights. And you already answered a lot of the common questions we receive about battery technology. Now, however, to all of those who are watching, if you still have questions, please remember to send them in via the chat box in your browser. And we will try to answer as many questions as possible in our Q&A session after the next part of our webcast. And for this third part of today's webcast, I'm happy to welcome our experts for high voltage battery recycling and battery life cycle management, Nicole Rostock from MAN and Christa Chilgren from Scania.
Hello.
Nicole, with the rapid transformation of the transport sector towards battery electric vehicles, batteries are used on a large scale. This makes it crucial to set up an advanced recycling strategy. Can you tell us which aspects have to be considered when setting up such a strategy?
Yeah, actually, there are some aspects that have to be considered when setting up a strategy for recycling. So first of all, what has a major impact are the different regulations in terms of batteries and waste management in the different countries. So those regulations are focusing strongly more and more on sustainability aspects in terms of preserving resources and protecting the environment. One example is the new battery regulation of the European Union. So this is now focusing strongly on recycling efficiencies, like you have to fulfill recycling efficiency not only on the whole pack, but you also have to fulfill recovery material rates and even to have recycled content in new batteries starting from 2031. So when we have a look at the slide here, we see what is the status within TRATON today. So for the whole pack, we have an average recycling efficiency recovery rate of over 70%. When it comes to the material recovery rates for cobalt, nickel, and copper, we have over 95%. And for lithium, we have around about 70%. So within TRATON, we use the same recycling network as the Volkswagen Group. And with the partners that we have today, we are fit for the future, I would say, because we already fulfill the targets of the new regulation even today. So this is one aspect that has to be considered. Another aspect is actually the development in the recycling industry itself. So because of all these regulations, we see that in the future, the demand of recycled content will increase. So a lot of companies see business opportunities there. So more and more companies are entering into this industry. We see a lot of startups claiming to have better recycling technologies with increased recycling efficiencies. So our target that we have is to really keep track, get a transparency of who is really capable of doing what along the value chain, and then decide who should be our partner in the future.
So the partner network is one thing. Another thing is, as Götz already said, there are different cell chemistries being developed and discussed. Does this also impact the recycling strategy?
Yeah, definitely. It has an impact because today the recycling industry is strongly focusing on the recovery of nickel and cobalt. So there you have established processes and partners that can handle big volumes, and you also have the demand for these recycled materials because they can even today be used in different products in different industries, for example, in products in the chemical industry, not only in the batteries. For LFP, actually, this is a different story. So to be frank, LFP batteries are not very popular in the recycling industry today because the only valuable material you have is the lithium. So when you only extract the lithium back, you will not be able to reach the target of the European Union for the whole pack, as we just saw on the slide. And if you're a recycler and you cannot fulfill those targets, then you're not a good partner for an OEM like us anymore. So at the moment it's very challenging, and there has to be some development in order to increase the efficiency rates for LFP.
So TRATON's approach for life cycle management is a circular economy. Christa, you are our expert for life cycle management when it comes to batteries. Can you explain to us how the closed loop, which is also a name for the circular economy, works?
Yeah, of course. So to understand the context, let's have a look at this illustration then. So it starts in the upper left corner with the raw material coming in, and as already discussed, we produce cells and then modules and packs, and we put it in a truck. And then we try to repair those batteries in the truck and keep them in the truck and reuse the batteries as long as possible. And when they cannot be reused anymore, we repurpose them and then sell them to battery energy storage producers who can build BESSes, which is a power bank that you can use for energy storage or grid balancing and so on. And then it comes back to recycling.
So the recycling is the last step of the closed loop. But how does it actually work? Nicole, can you explain this?
Yes, of course. Maybe we have a look at the next slide to better understand the process. So when it comes to recycling, first of all, the battery has to be deeply discharged first, and then it will be disassembled. So then it will be divided into different fractions and sorted. For example, you have the housing made out of aluminum, then you have the different cables made out of plastics and copper, and the electrical components. And then the main part are the modules with the valuable raw material inside. So those modules will be put into a shredder and crushed. So in the next step, all the solvent will be extracted, so it will be dried. And then in a few other steps, further purified, so that all elements like plastics and impurities will be deleted. And at the end, the output material will be black mass, and this is how it looks like. I have an example here. So this black mass will be at the same time then the input material for the next step, the so-called hydrometallurgic process. So in this process, this is the input material, and via chemical processes, you extract the valuable materials out again. And as an end product, you will have the so-called sulfates. So, and as an example, we have, for example, here the nickel, cobalt, and copper sulfate. And those sulfates will be then treated then in further steps, further treated so that it can be used in batteries again as cathode active material.
That's great, very informative. Thank you, Nicole. So I think we learned a lot about the life cycle and the recycling of batteries. And now it's the time already. We are coming to the end of our webcast. But before we finish up, we want to give you the chance to ask our 4 experts some questions. So if you haven't done so already, now is your chance to send in your questions via the chat function in your web browser. What is it you always wanted to know? And by the way, we are also welcoming back Christa and Götz and Stefan. Christa is still here, Nicole, of course, as well. So let's have a look if we received some questions. And I can see we have some questions. One question we received, and that's probably a question for you, Götz, is the battery strategy the same for Navistar?
Yeah, basically it's the same strategy. Of course, there are different boundary conditions depending on the market, but in general, maybe it's even more in Stefan's direction, but our modular system is of course valid for everyone, for every brand in our group.
Okay, another question we received in your direction. Are most of your trucks using LFP or NMC technology?
Yes, that's what we're heading for, to have these 2 chemistries for the next years to come to be our major cell chemistries. Yes.
And do we have a preference? Which ones?
It depends on the application.
Okay.
That's very clear. You have applications that require large range, high power. You will tend to use NMC. And if you have, let's say, short range or price sensitive application, then you will tend to use LFP.
Thank you. And Nicole, Krista, maybe one question for you. Why is the TRATON recycling rate for lithium much lower than the other raw materials?
So as I said before, the recycling industry was strongly focusing on the recovery of nickel and cobalt. So there you have established processes where you can treat high volumes. And lithium has never been in focus before because there was simply no demand for recycled lithium. So nobody needed it, so they didn't recycle it. But now this will change with the regulation coming up. So there will be more investments and technologies to get the lithium back as valuable material. So this is why the scale up is missing at this point.
Okay, let's see if we have some more questions. That's maybe another question for you guys. What do you see as the key barrier to broader adoption today?
In general, I would say the biggest barrier is the missing infrastructure, especially for commercial vehicles. So, as I mentioned, this megawatt charging, where the standard is set soon. So that needs, of course, the ramp up in Europe, for example. That's why, and that you mentioned also in your introduction, we have set up this joint venture with Milans to run that. So I would say the vehicles are ready, but now we need the infrastructure, and then the ramp up will come.
Another one, which probably is one for Stefan, about the platform. Do we already have a dedicated platform for battery electric trucks?
That's what I talked about when I talk about the modular kit. The modular kit is our future platform where we have common batteries, common installation spaces, common electronics and softwares across all brands for the battery electrical vehicles. They share also some with the conventional one of those interfaces, but that's actually what we are heading for. Today we have a little bit separated specifications, so we are very keen to get this done.
Thank you. And there are a lot of questions coming in, actually. That's good. Good to see. Okay, that's a cost question. How quickly do you think the TCO for BEV will match ICE vehicles? Maybe one which is hard to answer, or maybe can't be answered at all. I don't know.
It's not so easy to answer, and it's depending really on the boundary conditions. We expect it will not take too much long anymore until the TCO is reached. But of course, items like Maut and can support that shift to battery vehicles from the TCO standpoint. I don't want to name here really an exact year. It's so much depending on the boundary condition, diesel prices, and so on. So it cannot be so easy predicted, but there will be soon the year that TCO is reached.
Then there was another question: if you could repeat the truck space, kilometers per year, and days in use. Stefan, I think that was a guess.
Yeah, again, it's only an average which I mentioned there for long haul and for distribution. With our 500 use case, it cannot be precise, but the average, again, for long haulage is 130 to 160,000 kilometers a year, up to 250 days a year, and distribution 65,000 kilometers a year and around 350 days a year.
All right. Thank you. We'll have a look if there are more questions. There's one question. Are batteries expected to be core to TRATON in the long run, or do you expect larger scale players to enter the market and work as tier 1 suppliers? To you.
I don't want to disclose here our strategies, of course, but battery is one of the most important part in general, of course. What in the battery is then core or not, that we will not open yet. But of course, there will be a mixture of everything seen then used by suppliers depending on region and so on and so on.
Mhm. So let's see if there are more questions. I think there's someone, the question is a little bit unclear, but someone wants to hear a little bit more about megawatt charging, maybe when it will be available or some expectations on that. I don't know.
Now, first, the standardization is currently running, so we expect it will be set 2024. And it's, so this megawatt charging aims up to 1 megawatt roughly, so 1000 volt, and then as a maximum, that's, at least in Europe and US will be a standard, then a same standard. In Asia, there's some discussion ongoing. There the tendency is in a different direction, but it's a special connector, also a special plug which is designed to withstand then this 1000 volt and so on. So it's maybe too much to go in the details. It will be even a different webcast maybe for that, but yeah.
One question which I like is what has been the most exciting recent breakthrough in battery technology? From your perspective.
Good question. Oh.
Maybe then that we see that we are constantly evolving even better performance with existing technology, which was not expected in this sense. So why it's always many people so keen to have a new battery technology, but we're still discovering corners where we can extend the capabilities of the cell and the, let's say, the base technology that we have today with small tweaks and optimization on space usage and all those stuff. So that's what we see, and that's part in the cell and partly in the battery packs where we have even better, higher packaging rate and all those stuff. So it's really on this. When I'm really glad to see that we discover this more and more. So there's still a way to go. It's not finished yet.
Yeah. And I mean, it's one great thing to see that it's now also possible to do long haul trucks.
Absolutely, yes,
So-
absolutely.
Yeah. Let's have a look if there is more to come. So that's more a strategy question about our low emission strategy. Is it electric only or electric first?
No, in the long run, we will see the battery electric vehicle as the main technology. There will be use cases where maybe the battery electric vehicle is not the favorite. There could be others like fuel cells, like e-fuels, maybe even some specialties, but that are really niche applications. The main direction is battery electric vehicles. But also, again, depending on the market, which market, we are a global company. In Europe, it's battery electric vehicles, but there might be other markets where it's not so evolved yet with the infrastructure and so on.
And I see there are still questions coming in. Are our e-trucks built on the same production lines like the ICE trucks?
That's exactly the beauty with the modular kit that we are developing, that we are able to produce on one line all the different trucks and to optimize here also the usage in the factory. And we can, in this sense, also control a little bit what the market is requesting. So we have a little bit space to squeeze up and down, depending how the ups and downturns in the markets are. So that's also why we are so eager to get this modular kit, because, as I said already, we share some interfaces with the conventional powertrain and the frames and so on, so that we can use a lot of stuff across those vehicles.
Mhm. Then there is one question. Is there still a big trade-off between battery weight and how much payload the trucks can carry? And is government regulation helping with this?
Do you want to?
Yeah, actually, yes and no, and or yes and no and yes. The point is, yes, there's a trade-off. We are from a truck, we are deleting the heavy diesel engines and some other exits and those stuff. But on the other hand, the batteries are heavy. It's not a question about that. And there is regulations being on the path that allows electrical vehicle to be a little bit higher weight at the end. So the gross weight is higher. The battery is a little bit higher also than the conventional powertrain. So there's a delta, but I cannot say today what the delta is, because this may depend really on the application and the setup. In some applications, when you have a low number of batteries on the vehicle, it can even be a little bit lighter, depending. It's really depending on. But there are opportunities that let's say we have a penalty, but it's not that you have tons to lose. It's less than that.
And in addition, we have to add that a big portion of our portfolio is volume limited and not weight limited. That's also taken to be into consideration.
Absolutely, yes, yeah.
Yeah, thank you. So, let's see, do I have more questions? What role is Volkswagen's PowerCo expected to play in our battery strategy?
Interesting question. First, it's important to understand PowerCo is a kind of independent supplier, so they can offer us, of course, battery cells. If that is fitting then our commercial vehicle, and if they are competitive, then it's okay. Then, but that's a prerequisite, and that again, PowerCo as an independent Volkswagen is a different topic than with their competence, but that are two pair of shoes.
Okay, that's a tricky question. Would it be possible to combine BEV technology with fuel cell technology and have sort of a hybrid truck?
It's all. Oh, you want to answer?
Yeah. Actually, that's how we plan to use batteries in the fuel cells as well. So there will be, the setup of the battery is smaller than what we usually see on electrified vehicles, but fuel cells need to have support by a battery, and so in this sense, it's a hybrid system. That's, I would say, it's the answer on that. And we plan to use also parts from our modular kit. So it's not a separate development right now.
Okay, so yes, we are coming closer to the end. So if you still have questions, send them in now. We have 2 minutes left or so. And maybe there's one more question here at the moment. By how much do you expect the cost of a battery to fall annually?
No, that I will not answer in numbers. We see if that's it's even unclear if we see really a cost decrease annually, or if there's one or the other year even a jump up, as I explained, due to a raw material situation. In average, it will fall, but how much, how fast also new technologies are coming in, maybe faster than we expect now, like all solid state and so. Cannot give a percentage there. But in the past, we all were always surprised how much it was falling, more than everyone expected. But let's see.
Okay, so we are really close to the end, and I have no further questions here. Do you still have questions? So be quick and send them in. I'll keep watching if there's stuff coming in. Okay, I think there are no further questions coming in. We will close this session. Thank you very much for attending today. Of course, if you have questions, you can contact us and send an email. We will try to answer your questions. But meanwhile, thank you very much.
Thank
Have
you.
a good day.
Thank you.
Thank you.